a security company's own tool started stealing secrets, including the secrets of the AI assistants reading its code. On July 11, 2026, someone published a new version of jscrambler, a JavaScript protection tool. 15,800 downloads a week. Trusted by security teams specifically because it's supposed to protect code. Version 8.14.0 was not clean. An attacker had a valid NPM publishing credential. jscrambler itself confirmed it. Not a typo-squat. Not a fake package. The real one, hijacked. The install hook dropped a hidden file. Then it unpacked a nested, compressed payload. 7.8 megabytes. 3 separate binaries inside. One for Windows. One for Mac OS. One for Linux. It went after cloud credentials. AWS. Azure. Cryptocurrency wallets, MetaMask, Phantom, Exodus, seed phrases and all. Password manager vaults. Bitwarden. Browser cookies and saved logins. Session tokens for Discord, Slack, Telegram. And the configuration files of AI coding tools. Claude Desktop. Cursor. Windsurf. VS Code. Z. Socket caught the first version in 6 minutes. 6 minutes after it went live. But the attacker didn't stop. For more poisoned releases followed. Each one designed to survive the last one getting caught. The early versions used an install hook. Security tools know to watch install hooks. So versions 8.18 and 8.20 moved the malicious code directly into the package's main files. It ran the moment you imported the library. Or ran its command line tool. That trick alone bypasses ignore scripts. The exact flag developers use to feel safe. Here's the part that goes further than credential theft. And it isn't jscrambler's own trick, it happened 7 weeks earlier, in a separate campaign. In May 2026, researchers at Socket caught a single malicious package on PyPI. At Security Auditor, version 0.1.0. Published at 8:20 p.m. Universal Time Coordinated on a Friday night, built to look exactly like a security scanner a Web3 developer would want. Socket's own systems flagged it 58 seconds later. That one catch unraveled into 34 malicious packages, more than 384 versions, spread across NPM, PyPI, and crates.io, all within 72 hours. Socket named the campaign TrapDoor. They called it, quote, the first widely reported supply chain campaign that deliberately weaponizes the AI coding assistant, unquote. Here's what made it different from ordinary credential theft. Not hidden in a binary. Hidden in plain text files. .cursorrules. CLAUDE.md. The instruction files that AI coding assistants read before every single session. TrapDoor's packages inserted invisible characters into those files. Zero-width Unicode. Code points like U+200B. They take up no space on the page. Open the file, and it looks completely normal. But a language model's tokenizer reads them anyway. Hidden inside those invisible characters was an instruction. Run a quote, security scan, unquote. One that would quietly search for and exfiltrate secrets. Framed as a routine check. The AI assistant had no way to see the difference between that and a real instruction from you. Here's why an invisible character even works. A language model doesn't read a file the way your eyes do. It breaks text into tokens first, small chunks it processes one after another. Zero-width characters render as nothing on your screen, but they're still valid Unicode. They still become tokens. The model reads them like any other instruction, even though no human reviewing the file would ever see them there. Think about what that means. Your CLAUDE.md file is supposed to be a runbook. Guidance the assistant trusts, the same way a junior engineer trusts a written procedure. This attack turned that trust into the delivery mechanism. Detection requires printing the raw, unprocessed contents of the file. Because reading it normally, in any editor, shows you nothing wrong. If you maintain one of these files, there's a real check you can run today. In a terminal, print the representing of the file's contents, not just the file itself. Any character outside normal printable text will show up as an escape code instead of blank space. That single command is the difference between trusting a file you can't fully see and actually verifying it. jscrambler's own campaign, 7 weeks later, didn't repeat that exact trick. It didn't need to. It went a more direct route, straight at your credentials, but it kept adapting the same way. On Linux, it used eBPF, kernel-level code injection. On Windows and Mac, it checked for debuggers before running, then persisted through a hidden scheduled task that relaunched every 60 seconds. It exfiltrated data through a legitimate file-sharing site, and separately through Tor. JFrog identified the payload as a known family, IronWorm, built to self-propagate into other high-download packages, not just sit still in one. By the time jscrambler shipped a clean version, 8.22.0, 3 independent security firms had published their own analysis. Socket. Step Security. SafeDep. Each one found a different piece of the same attack. This makes 3 separate incidents in under a year, all aimed at the same target, something your AI agent already trusts. TrapDoor, in May, went after the instruction file directly. jscrambler, in July, went after the credentials and the AI tool's own config data. And last September, a fake postmark integration, a package called postmark.mcp, sat clean for 15 versions before a single added line started blind copying every email it touched to an outside address. Around 300 organizations had it running before anyone noticed. The lesson holds across all 3. If your AI agent trusts a file, a package, or a server, that trust is now something an attacker can hand it instructions through. And in every one of these cases, you would not have seen it by looking. Next Byte, documented, not hyped. New breakdown, every week.